Good day everyone! I'm your teacher for today. In this video, we will discuss about counting principles and probability. Before we start our discussion for today, we will read our objectives. At the end of this lesson, the students should be able to solve counting problems using the fundamental counting principles and define events, outcomes, and sample space through discussion. We will proceed to our lesson for today. Probability. What is probability? Probability is a branch of mathematics that describes chance or outcomes and is the chance that something will happen. Events cannot be predicted with total certainty. We can say how likely they are to happen. Probability is talk about the chances or the possible outcomes of the events. Okay, we have 5 fundamental principles. Basic counting principle, factorial notation, language of uncertainty, and experimental probability. And the last is expected value. Okay, A. Basic counting principle is uses the multiplication of the number of ways this event in an experiment can occur to find the number of the possible outcomes in a sample space. Okay, basic counting principle. We are going to use the multiplication to find our possible outcomes in our sample space. We are going to our example. Our example number 1 is Sophia packed red, white, and blue shirts and a green, black, and khaki short for a 3-day trip. How many possible outfits can she wear? We have here a 6 color. To find the possible outcomes, the possible outfits of Sophia, we're going to multiply the 6 color. We have a red, white, and blue in our shirt. And in our shorts, we have a green, black, and khaki. We are going to multiply it. 3 times 3 is equals to 9. So, the possible outfits of Sophia is 9.
Our next topic for today is about factorial notation. Factorial notation is a shorthand for multiplication of a list of consecutive descending whole numbers. So our symbol for factorial is like this. Our formula for factorial notation is n factorial is equals to n times n negative 1 times n negative 2. So now, I will teach you how to use this factorial. Let's say, present us to evaluate 4 factorial. The given is 4 factorial. 4 minus 1 is equals 3. 4 minus 2 is equals 2. So, write down 4, 3, 2, and 1. So, let's apply the multiplication. 4 times 3 times 2 times 1 is equals to 24. So, our factorial of 4 is 24. So, next example is 3 factorial. Always remember that 3 stands for n. 3 factorial it's equals to 3 times 2 times 1 is equals 6. And the last example, 6 factorial. 6 factorial is equals to 6 times 5 times 4 times 3 times 2 and times 1. That is equals 720. Now, let's have another example on how to use the factorial. Now, let's have this problem. First example, how many 3-digit numbers can be formed by the digit 1, 2, 3, 4, and 5 if the repetition is not allowed. Okay, in this example, if the repetition is not allowed, so we are going to form the first digit, the second, and third digit. So I use first digit 5. Write down the 5 is our first digit. 5 minus 1 is equals to 4. So 4 is our second digit. So now we are already used 2 digit for the first and second digit. For the third digit, there are 3 available digit. For our third digit, there are 3. So then we are multiplying each number. 5 times 4 times 3 is equal 60. Okay, but there is a second question. What if the repetition is allowed? So simple is that the example is 5 times 5 times 5 is equals 125. So the 5 is first digit, and the second digit is 5 again, and the third digit is 5. So we apply that if the repetition is allowed. So we can repeat any numbers from 1, 2, 3, 4, and 5. Language of uncertainty. First, experiment is an activity with an observable result. Outcome is the result of the experiment. Sample space is the set of all possible outcomes of an experiment. And the last one is event is the subject of all the sample space. Okay, the example of experiment is like you drawing a card or a roll dice. Those are the example of experiment. The example of outcomes, in a coin, toss the outcomes will be either heads or tails. Those are only 2 outcomes possible for tossing a coin. That is example for outcomes. Event. In throwing a dice, the event of getting a natural number less than 7 is a sure event. And lastly, the example of sample space. When you roll one dice, the sample space is 1, 2, 3, 4, 5, and 6. So the size of the sample space is 6.
Our next topic is about experimental probability. The empirical probability, relative frequency, or experimental probability of an event is a ratio of number outcomes in which specified events occur to a total number of trials, not in theoretical sample space but in an actual experiment. Experimental. What will we do about experimental? Yes, we experiment. Sinusubukan dito ang isang bagay. In this case, titingnan natin kung ilang beses lalabas ang isang outcome. This is the formula. Experimental probability, the number of times an event occurs over the total number of tails. Again, experimental probability, the number of times an event occurs, sa taas siya, over the total number of tails, sa baba. For example, 20 times akong nag-toss ng isang coin. At sa 20 times na iyon, ito ang naging resulta. Ngayon, titingnan natin ang resulta, tally, frequency, at probability. Para mas madali, we use a nice table. Okay? And ito yun. Dahil 4 na beses lumabas ang heads, maglagay tayo ng 4 na mark. At kung 4 na beses lumabas ang heads, ilang beses lumabas ang tail. At kung bibilangin natin, iyon ay 16. Right? Ngayon, meron tayong 16 marks. Next, what is frequency? First, count how much the marks. Ito ay bilang ng paglabas ng isang value o total ng ating tally marks. Para sa head, mayroon tayong 4. Para naman sa tails, mayroon tayong 16. O, ayan, maayos na ang ating data. Pwede na nating tingnan ang ating experimental probability, either heads or a tail. Ano naman yung over teacher? Okay. Paano naman natin gagawin iyon? Kung ang ilang beses mong ginawa ang experiment mula sa 20 times pagkatos ng coins, 4 times lumabas ang head dahil ang experimental probability ay number of occurrence over total number of tails. And the experimental probability of getting heads is 1 over 20. At kapag ni-Lewis term natin iyon is 1/5. At habang naman ang tails ay may experimental probability of 16 over 20. At ang lowest term naman ay 4 over 5. Naintindihan ba ang ating lesson ngayon? Very good.
Next topic is about expected value. Expected value is a concept used in situation in which it is desirable option with uncertain outcomes. The expected value of an action is the sum of the value of each potential outcome multiplied by the probability of that outcome occurring. You can also use expected value to distinguish the outcome of the weather, business, lottery, gambling, or even healthcare. But in this video, we are going to discuss about healthcare. Expected value scenario from non-trivial pursuits. Imagine you're at the FDA evaluating the expected value of patients taking a new drug, Superion. The drug succeeds in 60% of cases, and when it succeeds, it gives an extra year of healthy life and has no impact if it fails. So the question is, what is the expected value in years of healthy life of patients taking the Superion? Formula using the distribution method, we have here the EX equals X1 multiplied by P1 added to X2 multiplied by P2. We have a number of year which is 1 multiplied to 60%, which is probability value, added to 0 number of year multiplied by 40%, which is our second probability value. 1 times 0.60 equals 0.6 plus 0.40 equals 0. Since we have 0.6 added to 0, our expected value of success is 0.6%. That is how to solve an expected value of probability. That's all for today, and study our lesson because we will have a short quiz next meeting. Thank you.